All right, let's get started with this Ops Manager simple test installation, which we're going to perform on a single machine. This is an installation that lets us experience what Ops Manager feels like, understand a little bit about what the installation procedure is like, but not appropriate for production in the sense that it is not highly available. And we'll talk about the specifics of that as we get through this. So let's get started just checking out the documentation, which is docs.opsmanager.mongodb.com. Diving into these docs, if we notice under Introduction, we have this Install a Simple Test Ops Manager section. Now we're going to basically follow these instructions, maybe skipping over a few steps because you can do them yourself in depth, but I just want to show you how easy this all is. Now the first prerequisite is that we provision a server on your data center or possibly even in a local virtual machine. In my case, I'm going to do this on Amazon EC2, and that server needs to have 15 gigs of memory and 50 gigs of disk space. This is not appropriate for production, but for the quick test, it'll be just fine. I've just SSH'd into the machine that I'm going to perform the installation on. And if I look at the instructions here, really the first step is to configure our package management system so that we can install the latest version of MongoDB. So the first thing we need to do is run this command, and doing so will allow us in a moment to get MongoDB installed. We'll follow this command here to install MongoDB. And you might ask, why are we installing MongoDB first before we install MongoDB's Ops Manager? And the answer is simply that, unsurprisingly, Ops Manager uses a MongoDB database for its own back-end persistence. In other words, really all the state that is stored in Ops Manager, whether it's monitoring metric data or metadata about backups or automation management configurations, all the stuff you can do with Ops Manager, all that information lives inside of a MongoDB database that we refer to as the Ops Manager application database. So we've just installed MongoDB on this machine. I'm going to follow the instructions to create a data directory for it real quickly here and ensure that the data directory is owned by the MongoD user, which is the default system user on Linux for the flavor of Linux I'm using, which is Amazon Linux. Ubuntu, I believe the default user would be MongoDB. Otherwise, very similar procedure. And separately, the instructions are pointing out that I can optionally do the same for a backup database. I'm going to do that. To explain what that's all about, well, Ops Manager by default uses two databases. One, the one I just mentioned, the Ops Manager application database. And separately, it uses a database to enable the backup system. Now, at the very least, this backup database is used to persist oplog, which is what enables our invisible secondaries to maintain a essentially replica that can be snapshotted for purposes of backing up. And also that oplog is utilized via our point-in-time restore capability, such that when you want a restore up to a particular moment in time, the oplog can be applied up to that moment in time. Next step here is to run a couple of MongoD start commands. Let's do that. Great, we've just started a MongoD on the default port for our Ops Manager application database at /data/appdb, the one we just created. Started successfully, wonderful. And now we're going to do the very same thing in this example for the backup database. And we're going to start it on port 27018, different port of course. And that database is using data/backup. So we just started two standalone MongoD processes. Now in production, both of these would ideally be replica sets to maintain high availability, where those replica sets would be spread across multiple machines, so that a loss of any single machine would of course mean that we still would have the ability to continue operation in that degraded state until we replace that replica set member with a new machine. So for the purpose of testing though, two standalones are just fine. Now we see that we can download the Ops Manager package as the next step. That makes perfect sense. Let's check out mongodb.com/download and see what we have to do to fill all that out. Well, this takes us to the nice download center. If we flip over to the Ops Manager tab and look at the options in terms of Linux flavors and other operating systems, we see Windows is on this list as well, Ubuntu. Well, we're on the Red Hat, CentOS, SUSE 11, Amazon Linux flavor here. I happen to be on Amazon Linux, so I'm going to select that one. And I'm going to use the RPM because that makes things a lot easier for me. The package management framework basically sets up all the directories and system users as I need them. We also separately offer a tar.gz file, but that puts a lot more onus on you to worry about things. So let's go with the RPM by default. If you have permissions to install packages, that's the way to go here. Click download. We're going to be asked for a quick bit of information here. Click submit. What I actually need to do here is, since I'm SSH'd into a machine, what I really need is the link URL that tells me where I can download that RPM, so that I can right-click on that download not starting link and confirm, okay, I need just the RPM part of that URL here, not the rest. Great. That's what I need. Now I can jump back into the machine that I'm SSH'd into, and I can perform the download. So now I'm going to download the Ops Manager package after ascertaining its URL from the mongodb.com/download downloads page. So I'm going to run the download command here for the RPM. As the instructions tell me, I can now install Ops Manager. Now that I've downloaded it, I can run sudo RPM and this little command here in the file I just downloaded. There we have it, the sudo RPM command to install Ops Manager, and now we're installing it. The process and package name has this MongoDB MMS, where MMS is a sort of genericized term meaning MongoDB's management service. As our documentation explains, this created a couple directories for us, as well as the MongoDB-MMS user, the system user that Ops Managers run with. It also created an important file called conf-mms.properties. This is basically where we configure the critical piece of Ops Manager, and that is we tell Ops Manager how it can reach the Ops Manager application database that we spun up earlier, which we spun up locally on port 27017. Now, by default, this conf-mms.properties file, and I can show this to you, is actually already pre-configured to point to localhost 27017. So if I cat this file and scroll up in it, we will see, I hope, the mongo.mongo URI is configured as default to be 127.0.0.1 at port 27017, localhost in other words. Now, the great thing about that is that's exactly where we started our application database, so we don't need to do anything here. We should be good to go since we already started a local database. The next step in the procedure is to simply run the sudo service mongodb-mms start command. We'll run that. And now we see the Ops Manager startup. Really what this is doing is checking to do some sanity checks around configurations to make sure that Ops Manager can reach its backing database, the one we started earlier. And also basically starting to fill out that blank database with the data structure that Ops Manager expects to write to it in. So there's a little bit of configuration at this step. It'll be completed within a few minutes typically. Okay, great. We can see that the Ops Manager application has started, as well as the backup daemon subprocess, which we'll talk about in a moment. All right. Now that our Ops Manager has started, we can actually go into the web browser and check it out. So if I confirm what my host name is here, there it is, public DNS name on EC2, I can plug that into my web browser, specifically at port 8080, which is the default port when SSL is not being utilized. Again, for production, you typically would want to be running with HTTPS. But here, for a test, no big deal to use 8080. Boom, and there it is. So here we see MongoDB Ops Manager is up and running. The application server we just started in the machine we were SSH'd into is what is making this available to us. Now, the first thing that we can do here, really the only thing we can do at this time, is click register. Now, doing so will actually allow us to create the very first global administrative user on our Ops Manager. We're also asked to create a group. This is the very first group that we'll have in this Ops Manager installation. I'm going to call it very creatively first group, but you can call it anything you want. And we check the evaluation agreement, which is there because we're using this for development, presumably, which is totally free to do for evaluation and development. So now I can click Create Account. And now the first thing that we land on here after registering this first account, because we're the first global administrator of Ops Manager, is a configuration flow. Now this is not something that other registrants will see later on. We see it only because we're the admin user, and we're asked to configure various attributes of Ops Manager up front. First thing we asked to do is type in the URL that will be used to access Ops Manager. Well, unsurprisingly, it's the same URL that we just typed into our browser. I'm adding it in here, and you might wonder, why does that need to be written? Well, writing it here allows this to be persisted in our Ops Manager application database, and therefore utilized later when Ops Manager needs to know things like what the access point is in the internal network for Ops Manager. This allows our agents to, for example, understand how they can reach back out to Ops Manager later on, those kinds of things. We're asked for our HTTPS PEM key file, which since we didn't use HTTPS here because it's a test install, we're not going to provide any information about. Some load balancer settings, again, we're not doing that, it's not production. I'm going to type in an email address here that is what I would be using for my Ops Manager administrator's email address. I'm just going to use my default email address here. I'm also going to select the SMTP email server options that I'm going to be using and the host name for the SMTP server. Now, I happen to know that on localhost, I have a SMTP email server running, and it's going to be on port 25 by default. If you have another email service running in your organization you prefer to use, you can, of course, configure that here. I'm going to leave all of these to the default options and click Continue. And we see some other options. User authentication method. This is asking us whether or not Ops Manager should check its passwords for authentication purposes against its locally stored user directory, or if instead you want to use LDAP, you can change these later on as of the Ops Manager 2.0 release. So I'm going to leave it as the default for the purpose of the test install, certainly. And then we have a bunch of other optional settings that can be set. I'm going to leave them all to their defaults, but you can read about all of them in the documentation. Finally, a few more settings: HTTP, HTTPS proxy settings, Twilio integration, and how our Ops Manager automation and backup system will ascertain versions of MongoDB, whether they're going to be available via an internet network connection or whether your database nodes will not have internet connection and therefore you need to use local mode. Well, for purposes of testing, I'm going to stay on the internet mode, but a lot of enterprises certainly do not allow outbound access to the internet from their data node. So in that regime, you'd click local here, which does mean a little extra work later on, making sure that the versions of MongoDB you want to use are available on the Ops Manager application server. Now, I'm going to leave everything else to the default here and click Continue. We're finally in. Ops Manager is set up and ready to go, and we can see the landing page for our very first group. This is pretty cool. Another thing I'd like to point out is in the very top right, there's an admin button. This admin button only shows up because I'm a global administrator on this Ops Manager install. If a subsequent person were to register here on this Ops Manager, and I didn't make them an administrator myself, they would not see this button. So let me show you what this button offers to folks who do have that administrative capability. Well, this is kind of the global view rather than at that group context that we were looking at a second ago. And actually here we can see that the Ops Manager configuration that we just set is configurable, so we can make changes to it. I would caution that a lot of the changes, this double star tells you, if you make changes, some of them will require an Ops Manager application restart. What I really wanted to show you is if we go into the backup section, there's an important initial configuration that we need to do before we can really feel like this Ops Manager is fully ready to go, or at least this test installation is fully complete. And that is that while we have a backup daemon running as part of our Ops Manager application that we started earlier, we need to define a directory that can be utilized for our head databases. And that is the case for any Ops Manager application instance that you're going to have running the backup daemon. That is essentially an Ops Manager application instance that is persisting a copy of a replica set you're backing up. Well, we need to define where those backups are going to be maintained locally. Now, if we go back to the install simple test procedure that we were looking at earlier, jumping ahead to where we want to be, we can see that the procedure actually suggests creating this directory, data/backup daemon. So let's go do that on our machine. Make dir data backup daemon. We've created the backup daemon directory. And now importantly, we need to remember to set the MongoDB MMS system user, that is the user that Ops Manager's application is running as the owner of that directory. That will ensure that Ops Manager's application backup daemon can write its quote-unquote heads, which are these sort of secondaries of the replica sets we're backing up that are invisible, that the clients don't know about, can write them there. Now that we've done that, we can go back into the backup setup page, type in the URL that we just configured, which is data/backup daemon, and click set. Ops Manager is going to do a quick sanity check to make sure that it does indeed have access to that directory and should report back when it does. Great. Now that that path has been found and it did a quick check on the disk space, I can click Enable Daemon, which actually makes this backup daemon eligible for taking backup jobs, which are backups of particular replica sets that are managed within your Ops Manager installation. And now we have to make an important decision. We have to decide whether we're going to configure our backups snapshots to be stored on the file system or separately in a MongoDB database, which we call the block store. Now, the benefits of the file system storage is that basically you can mount network accessible storage, and as long as you can mount that file system storage from all of your Ops Manager application instances, and you may run many when you're in production, as long as you can mount them all at the same path on the file system, then this enables you to be able to write those backup snapshots, and then after the fact, if you want to, you can move them around or copy them using standard file system utilities, which can make your life a lot easier if you want to move those backups to archival media, tape, etc. Probably the biggest drawback to the file system storage, you're not going to get deduplication because each snapshot is going to be written to a separate subdirectory. unless you have transparent deduplication built into your SAN, say. But the advantage of the other option here, which is the database storage, our MongoDB block store, is that it has built-in deduplication. Those snapshots are actually stored in a live running MongoDB replica set. So the downside to this one is that you have another MongoDB replica set or multiple replica sets to keep up and running, and the snapshot files are less accessible because they have to be restored out of there. In other words, you can't just use standard file system utilities to access them where they're stored. So I have two options here. I could click Configure File System Store. If I did so, all I'd have to do is type a path in, like my file system store 1, and then I just have to make sure that this is symlinked to whatever I've mounted and can mount from all of my Ops Manager application instances. I'd click Save. Or separately, if I were to click Configure a block store, I'd be asked to provide a host name and port, like for example, localhost 27018, which is that second database that we started, which we need no matter what, whether we're using the file system store or the block store, because that one we started was also for oplogs. I could configure that and click Save, and separately I could use the block store. Now this means that if I go back to a group, if I were to deploy a replica set and start backing it up, it would back up to one of those two that I configured.